Technology is evolving faster than we can explain it. This week, the pace of innovation has once again left us astounded. IBM has unveiled an optical chip that could propel AI computation to speeds 5 times faster than anything we've seen before. At the same time, researchers have brought science fiction into reality with the world's first truly interactive 3D hologram. Meanwhile, a new large language model from China has emerged that might rival even the giants of the Western AI world. These breakthroughs, alongside striking new discoveries in vision science and material engineering, are shaping our collective future in ways that would have seemed impossible just a few years ago. Let's dive into 5 of the most groundbreaking innovations redefining what it means to live in the era of modern technology. IBM scientists announced a fundamental leap forward for artificial intelligence hardware. An optical AI chip capable of executing machine learning tasks up to 5 times faster than current state-of-the-art silicon. The secret lies in the chip's architecture. Instead of using electrons, the charged particles that have powered computers for nearly a century, this chip relies on photons, the elementary particles of light. By channeling data through light pulses rather than electrical charges, the chip can simultaneously process massive streams of information, all while dramatically reducing power consumption. Silicon photonics, the technology at the heart of this chip, merges the world of fiber optics and microchips, allowing lasers and detectors to be built directly on the same silicon wafers found in everyday computers. This is especially powerful for edge computing. Think of autonomous vehicles, wearable AI assistants, or satellites in orbit, environments where energy is at a premium and data throughput can be the bottleneck. Imagine smart cars that react instantly to their surroundings or AI systems in space exploration that function far beyond current power constraints. By harnessing light itself, IBM's chip points to a future where the boundaries between speed, efficiency, and miniaturization are radically redefined. The next generation of AI might not be electric, it could be optical. But while hardware speeds ahead, software innovation is no less explosive. This week, the Chinese AI firm DeepSeek captured global attention by releasing an open-source large language model, making advanced AI more accessible than ever. What makes this model stand out? Affordability, versatility, and, crucially, open access for developers worldwide. Early benchmarking suggests DeepSeek's model holds its own beside some of the best, including GPT 3.5, especially in complex reasoning and multilingual comprehension. By offering enterprise-grade language processing capability at a fraction of the operating cost, DeepSeek lowers the barrier for startups, educational institutions, and independent inventors, particularly in countries where resources are limited. This move has profound implications, democratizing AI technology and accelerating the pace of global innovation. As open-source ecosystems thrive, we're witnessing a new era of global collaboration, where the capacity to build with AI is no longer restricted to a handful of tech giants, but open to anyone with the curiosity and ambition to experiment and create. And if you thought interactive holograms belonged exclusively to the realms of Star Wars or futuristic daydreams, think again. A team of researchers has unveiled the world's first tangible, interactive 3D hologram. No special glasses, no screens, no virtual reality gear required. The breakthrough employs precisely tuned ultrasonic waves, allowing the manipulation of microscopic particles suspended and shimmering in mid-air. The result? Floating images that hang above your desk, viewable from any angle and, astonishingly, responsive to your touch. These dynamic holograms can rotate, change color, and react to gestures. They're not just for looking. With haptic feedback, you can actually feel them. The possibilities explode from here. Virtual models for education that you can examine and interrogate. Intricate simulations for doctors and engineers to manipulate directly, game worlds leaping off the screen into physical space, and even remote meetings where your colleagues appear as floating, tangible avatars. The only limit is imagination, as this crossover between digital and physical heralds a totally new genre of human-computer interaction, one that feels as natural as reaching out your hand. As if reshaping physical reality weren't enough, scientists at a leading visual neuroscience lab have redefined the realm of color itself. In their controlled study, they created a perceptual color called olo, a hue the human eye has never knowingly seen. Olo lives in a space between green and orange, but escapes true classification as either. Through carefully calibrated lighting and mapping of neural responses, researchers discovered that it stimulates combinations of cone cells in the retina that no natural color in the world can achieve. This isn't just imagination or false color. It's a real, stable perception visible to the human eye but missing from nature and art until now. The implications are vast. Artists, designers, and engineers might exploit olo and future unique colors for new visual experiences, interfaces that minimize glare and fatigue, or new forms of camouflage that evade human detection. Just when we think humanity has seen it all, science finds shades that expand the spectrum of perception itself. Groundbreaking visual experiences demand materials that can keep up. Enter a new era of supermetals. Scientists have engineered an alloy structured at the atomic level to withstand temperatures above 2,000 degrees Celsius, over 3,600 degrees Fahrenheit, without warping, deforming, or losing its core strength. Built from a blend of rare refractory elements and featuring an ultra-dense lattice, this material is tailor-made for the harshest environments known. Think hypersonic aircraft streaking through the atmosphere, spacecraft enduring re-entries inferno, or components at the heart of nuclear reactors, systems where current metals buckle and fail. This new alloy rewrites the rules of engineering, allowing designers to imagine vehicles and reactors that surpass even science fiction extremes. As we continue to push further into the high frontier, the marriage of molecular precision and exotic elements offers tools for a future well beyond our planet. From thinking faster and speaking smarter to bending light, color, and even matter to our will. This week's advances remind us how far technology is advancing and how quickly horizons shift. The world of innovation is no longer just about building smarter phones or smaller chips. It's about rewriting the boundaries of how we interact with reality itself. Advances like optical AI chips, interactive holograms, perception-defying colors, and ultra-resistant materials hint at a world where science and imagination walk hand in hand. If this excites you, stay with us every week as we bring you the front lines of innovation, exploring tomorrow's breakthroughs today. Until next time, stay curious, stay connected. Science is just getting started.